Hi everyone. Today we'll be discussing a very important concept from Langchain, that is fallbacks. So basically, what are fallbacks? So you must have seen try and except cases in Python. So you can take it as a similar thing, but a little modified. So in case of Langchain, we are adding up multiple components, multiple chains to create a complex solution. At times, some of the components might fail and eventually breaking your whole solution. So fallbacks comes with an alternate solution if your pipeline breaks down. This is the whole use case of fallbacks. So here we'll be discussing out two major examples that will help you understand how fallbacks works. So let's get started. So first of all, uh, do pip install langchain and openai for now and hugging. So here you can see that I'm creating a prompt template, name an entity, output just the name. So entity is the variable. So I think all I have already explained what are prompt templates and what are LM chains in my previous code. So you can refer to that. Once I have created this prompt template, I am creating two LLM objects. One is using OpenAI, and here you can see that the API key that I'm mentioning is wrong. If you have seen the OpenAI API key, it's long, so I'm just giving it a dummy API key so that it breaks. Intentionally, I'm breaking the code. And the second LLM that I'm bringing in is from Hugging Face Hub. So I'm loading. So I've already explained in a previous video how you can use Hugging Face Hub to load Hugging Face LLMs in LangChain. So one LLM I'm creating using OpenAI, other I'm creating using Hugging Face Hub. Now this line is very crucial. Hugging Face LLM with fallbacks. So in this case, what we are doing, if the OpenAI LLM fails, do use Hugging Face LLM with fallbacks, and I'm the list object. I'm providing the name of the Hugging Face LLM. That's the only thing that we need to do. Now eventually LLM dot invoke tell me a joke. As you can see that I like to eat a lot of ice cream. So take it. It's a random take that is given because Flan T5 the performance is not great. But here you can see that the code didn't break. Even I've given it a wrong API key. This is because of the fallback. So internally, OpenAI LLM did fail. But for now, as we have provided with the fallback Hugging Face LLM, eventually once the OpenAI LLM failed, it went to the second LLM that is provided in the fallback, that is Hugging Face LLM, and eventually it gave a result using that. So if you wish to test it out, so here you can see that it is mentioning that I have an incorrect API key. And once this LM gets invoked, internally also the same error would have come, but this has been saved by the fallback that I have given. Now the next example I'm showing you is that where the LMs are fine, but eventually I have made a wrong pipeline, long elements in the chain that I'm trying to create. So I will keep the same example, name an entity, output just the name, or the prompt templates. I'm loading the LLM Hugging Face up. So this time using this particular LLM, I'm not using the OpenAI LLM, I'm using the Hugging Face Hub LLM. Now there is a bad chain that I'm creating. So I'm creating an LLM chain, LLM prompt, and then passing the date time output parcel. So this is basically Langchain LCEL format that I'm using. So instead of coding out everything the pydantic way, you can even use this particular language. Like if you wish to chain out multiple components, you can mention pipe and then the component itself. So after the LLM chain, I'm trying to add a date time output parser. Now, if you read the prompt, name an entity, output just the name. In this case, you won't be getting any date time object in the output, right? So eventually, this chain object will break. Now I'm creating a good chain object, that is just the LLM chain and without an output parser, right? Now here you can see that bad chain dot with fallbacks good chain. So in the above case, we were passing a fallback LLM for a bad LLM. Here we are passing a fallback chain for a bad chain that I've created if the code breaks. Now, if you see, I'm invoking good chain dot invoke the LLM object entity colon fruit. So I'm getting this output. Now, if I invoke chain dot invoke fruit, the output remains the same. But now if I run it for the bad chain, it should break. Because yes, as you can see that the output parser is at the wrong place. So here you can see that once the bad chain breaks internally, it automatically shifts to the good chain that I have created. And fallbacks helps us from breaking our application. So this can be a very good solution when you're going for production grid Langchain applications.